Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on August 14, 2025, about 6 days ago. The big hook is that this paper makes the case for diffusion language models as a strong alternative to autoregressive systems, highlighting parallel text generation, bidirectional context, and iterative refinement that together deliver competitive quality with much lower latency. The paper is titled, A Survey on Diffusion Language Models, and as we will see later, the implications for training and deployment are quite significant. Beyond the overview, the survey maps techniques for training, post-training, and inference, and outlines open challenges for scaling and multimodal reasoning. Building on that, multiple tweets praise the survey for clear mapping of diffusion language models, emphasizing faster inference, bidirectional context, and finer control, with one noting nostalgia for continuous approaches. Engagement looks moderate to strong, with around 100 likes on a highlighted post. Also, the authors shared an official GitHub repo. It's a curated, awesome list for diffusion language models. You'll find a timeline image, an organized README with sections like playgrounds, must-read papers, discrete and continuous DLMs, multimodal works, training and inference tricks, applications, and lots of recent references. Alright, this timeline maps the evolution of diffusion language models from 2021 through 2025, with a curved arrow showing growing activity. Focus first on the full chart to see clusters by year and 3 color codes: green for discrete methods, yellow for continuous, and pink for multimodal. Moving upward, the 2023 to 2024 segment shows a shift toward discrete approaches. At the top right, the latest entries highlight multimodal systems and commercial efforts, reflecting increasing throughput and broader applications. Next, this trend chart shows research volume over time. Focus on the full plot first, where the x-axis spans 2021 to 2025 to date, and the y-axis counts papers. The green bars represent discrete models, and the brown bars represent continuous models. Building on the timeline we discussed, the green bars surge from 2023 onward, while the brown bars stay modest. The dashed green curve projects rapid growth into 2025, with a hatched section indicating in progress counts. Okay, this taxonomy diagram organizes the field at a glance. Start by scanning the full chart, which branches into 4 columns that map paradigms, training strategies, inference and optimization, and applications. Moving down the first branch, you see continuous space, discrete space, and hybrid models, each with example systems. Then the next branch lists pre-training and post-training methods, including policy gradient and preference optimization. Continuing rightward, the inference branch highlights parallel decoding, unmasking, and guidance, plus efficiency tricks. Finally, applications span multimodal, conventional tasks, code, and biology. Moving to the summary table, you get a compact catalog of major diffusion language models, aligned by 5 columns: parameter scale, diffusion type, noise schedule, target task, and training data size. Notice the diversity. Discrete and continuous approaches both appear, with noise schedules ranging from linear and log linear to cosine and adaptive. Building on earlier context, the rightmost column shows data scale climbing from tens of billions to trillions of tokens, while tasks broaden from pure language to code and multimodal settings. Alright, focus on the full grid first. It contrasts training on the left with inference on the right across 4 rows: autoregressive, discrete diffusion, continuous diffusion, and block diffusion. Building on our taxonomy, notice attention patterns: causal for autoregressive, full for both diffusion families, and block causal for the hybrid. Next, trace the right column. Step-by-step next token for autoregressive, iterative unmasking for discrete, iterative denoising for continuous, and blockwise unmasking for the hybrid, showing how parallelism emerges. Building on that side-by-side comparison, 2 takeaways stand out. Diffusion language models deliver native parallelism with bidirectional context, yet maintain competitive quality through smart training and inference tricks. A diffusion language model means text is generated by iteratively denoising, refining tokens in parallel. The road ahead targets long sequences and better dependency modeling. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.